final lesson on numbers before we go into characters, images, sound, etc. And this is important because particularly for images, maybe colour and things like that, we use hexadecimal a great deal. So we're going to deal with hexadecimal in this lesson, explain what it is, how it's used. There's no real new maths involved, although you will be converting between denary, binary and hexadecimal, but it's mainly pattern spotting rather than doing any maths. You've learned all the maths that you need. So let's take a look. Let's go back to this pattern. This is a nibble, and this is a nibble in order, if you can remember the pattern. I've asked you to practice this, write it down on your exam paper, because it is important. And really, this is where it starts to become very important. So take a look at the columns. The first column is 0, 1, 0, 1, so on. Second column is 2 zeros, 2 ones. Third column, 4 zeros, 4 ones, and we're doubling each time. Last column, 8 zeros, 8 ones. So practice writing that down. And what that is, that stands for the binary equivalent of the following denary or decimal numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. Now, that's nice. You're used to decimal numbers or denary numbers. You're happy with 15. But when we've got large numbers, if I'm into the millions or billions, then even denary numbers tend to be very difficult to read. And the computer kind of naturally lends itself to using things called hexadecimal numbers, which are base 16. So there's 16 items here, and we are going to have single digits representing each one. So here we go. I've got my hexadecimal column down here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's as many single digits as I can use. And I need to move on and represent 10, 11, 12, 13, up to 15. Now the problem is that I need to use some kinds of symbols. I could use smiley faces, or I could use sort of hearts or spades or clubs. But I really need them to have a sort of universal order so that everybody knows what order they come in. And the best way of doing that is to start using the alphabet and starting at A. So we write down for 10A, for 11B, for 12C, D13, E14, F15. And that way we just use a single digit to represent all of these. So when we go into the double digits from 10 onwards, in hexadecimal we just use a single digit. And that's its purpose, and that really makes it very easy for humans to start reading and understanding binary numbers. And we'll take a look at that now. So if I've got this binary number here, 1101, all I need to do is look down this column here to find the matching pattern, 1101. It's 13 in decimal, but in hexadecimal it's the value D. That was fairly easy. Here I've got an 8-bit number. Now it's beginning to start looking a little hard. Number one, you've got to count the number of digits to make sure there's 8. So it's a lot easier if we kind of separate these out into two nibbles just by putting a space in the middle. So it looks like this. And then we can use our table to go and find out what these two values are. So 1001. Look down my table for 1001. In hexadecimal it's 9, so I write down 9, and then I've got 0110, which is here. In decimal it's 6, and in hexadecimal it's also 6. So my answer here is 96 in hexadecimal. Let's go on to 16-bit. Now it's getting really difficult to sort of read and focus on what we're doing. So we can again just break this up into nibbles so that we can see it a little clearer. So I've got 1110, 1001, 0110, 1100, and now I can just look down my binary nibbles and find the matching hexadecimal pattern, not the denary one. It doesn't work with denary. You can't just write down 10 then 11. It has no meaning. So let's find this one. Treble 10, so that is down here, that's an E. Then 1001, we've done that already, that is a 9 in hexadecimal. Then 0110, that is a 6 in hexadecimal. Then 1100, look down here, 1100 is C. So I end up with the value E96C. And I don't leave them separated as per nibbles, I put them all together as for any particular number. So this is the binary and this is the hexadecimal. Now that's fine, but I did mention at the start converting, and we already know how to convert sort of these numbers into denary, and we can use what we already know to help us. For example, let's start off with this one before we go into conversion. Let's write, or if we're given a hexadecimal number and we're asked to convert that to binary or denary, I've got 03AF. I could split it out, 03AF, and go and find out the binary equivalents. So 0 here, the binary equivalent is 4 zeros. 3 hexadecimal, the binary equivalent is 11 or 0011. A, look down the column for A, the pattern is 1010. And finally F, look down for F, 4 ones. Good, take all the spaces out, and now we write a 16-bit number. So let's get on to a little bit of conversion. Hexadecimal to denary, how do I do it? I'm going to take the last two digits from the last number that we looked at, AF. So I'm going to do the same thing. Write down my AF in hexadecimal, split it up so that I've got space to write my binary numbers. Then I'm going to look for A in the column and find its binary pattern, which is 1010. Then I'm going to find the F in the hexadecimal column, look at the binary pattern, 4 ones, and then I'm going to write out my table as I did before, converting from binary to decimal. So I start with 1, double it, 2, 4, 8, 16, 32, 64, 128, and then write down my binary number in there, 1010, and then my 4 ones. So I've gone from hexadecimal to binary, and I've made out my table. And all I need to do now is just do the sum for wherever there's a 1. So it's the same conversion as before, binary to denary. So I've got 128 plus a 32 plus an 8 plus a 4 plus a 2 plus a 1. With or without calculator, we get 175. So that's gone from hexadecimal to denary, but we've got this sort of intermediate process here where we convert it to binary first, so that we can do that conversion. That's the best way of doing it. And we can do it the other way around as well. So we can take a denary number and turn that into hexadecimal. So here I've got the denary number 133. So again, we write out the table 1, 2, 4, doubling all the way up to 128. And then we do that subtraction. So 133 is greater than 128. So we put a 1 in the 128 column and we take the 2 away. 133 minus 128 is 5. Well, I'm getting used to it now. So just looking to make 5, I need a 4 and a 1. So I put a 1 underneath each one of those. And then I fill the rest out with zeros. Then I pull this number out. So I've got it below and I separate it to make it easy to see. So I've got 1000 and 0101. So there's my 2 nibbles. I look in my columns for these patterns. So 1000 is 8. Oh, don't forget we're converting to hexadecimal. And 0101 is here, which is 5. So it's 8 and 5. Put them together, 8, 5. The problem is, as I mentioned before, you can make a mistake here by thinking that's 85. It is not. It's 85. I know we say this is 133, but it would be nicer to say it's 133. And really we need those subscripts to tell us what numbers we're working with. So this is 133 in denary, base 10, and this is 85 or 85, in base 16 or hexadecimal. And that's it. Denary to hexadecimal, hexadecimal to denary, how to convert, what it all means. Your turn for some exercises now.